Picture this. The storm rolls in like nothing you've ever seen. Dark clouds boiling across the sky, lightning crackling every few seconds, and then it happens. A massive surge tears through the electrical grid. Every unprotected device within miles just dies. Phones, radios, medical equipment, gone. In a post-apocalyptic world, losing your electronics isn't just inconvenient, it could be fatal. I'm here to teach you how to protect your precious electronics from the electromagnetic nightmare that comes with these superstorms, and I'll be honest, I learned most of this the hard way. So what exactly kills your electronics during these storms? Two main things: electromagnetic pulses, or EMPs, and lightning surges. Think of an EMP like an invisible wave of energy that floods through the air. When lightning strikes or certain types of storms build up enough charge, they release this wave. It doesn't care about your walls or your backpack. It passes right through and induces electrical currents in any conductive material, like the circuits inside your phone or radio. Those delicate circuits weren't designed for sudden power spikes. They overload and burn out instantly. Lightning surges are more straightforward, but just as deadly. When lightning hits power lines or even the ground near your shelter, it sends a massive spike of electricity through anything connected. We're talking thousands of volts looking for somewhere to go. The good news, both of these can be blocked with the right kind of shielding. The better news, you can build that shielding from scrap materials you probably have lying around. The solution is something called a Faraday cage, named after some old-world scientist. Don't worry, the concept is simple. Metal conducts electricity, right? So when that EMP wave hits a metal enclosure, the metal itself absorbs the electromagnetic energy and channels it around the outside of the container, leaving the inside protected. It's like a metal umbrella for electromagnetic radiation. The key rules are: the enclosure needs to be conductive metal, it needs to be completely sealed with no gaps, and your electronics inside cannot touch the metal walls. That last part is crucial. If your device touches the metal, it becomes part of the cage, and all that energy flows right through it. Now let me show you how to actually build one of these things with materials you can scavenge. First, you need a metal container. I'm talking old ammunition boxes, cookie tins, metal filing cabinets, even a clean metal trash can works. Aluminum foil can work in a pinch if you layer it thick enough, but rigid metal containers are always better. I once spent an entire afternoon gathering every metal box I could find in an abandoned office building. Let me tell you, carrying a stack of filing cabinet drawers through a thunderstorm is not my finest moment, but desperation makes you creative. You'll also need insulation material: cardboard, cloth, foam padding, bubble wrap, anything non-conductive to line the inside. This keeps your electronics from touching the metal. And finally, something to seal the edges. Aluminum foil tape is ideal, but regular duct tape layered with aluminum foil works too. You're trying to eliminate any gaps where electromagnetic radiation could sneak through. All right, let's build this thing. I'm using a metal ammunition box as an example because they're sturdy and have decent seals already. Step 1. Line the inside. Cut your cardboard or foam to fit the bottom and sides of the container. You want at least a 1/4 inch of insulation between the metal and where your device will sit. I usually do a 1/2 inch just to be safe. Make sure you cover every interior surface. Step 2. Place your device inside. Wrap it in cloth or put it in a plastic bag first for extra protection. The goal is to create a cushioned, non-conductive nest for your electronics. Step 3. Close it up. This is where I messed up the first time. I got excited, slammed the lid shut with way too much force, and the impact was so hard, I heard something crack inside. Note to self: gentle closure. Your device is protected from EMPs, not from you being an idiot. Step 4. Seal the edges. This is critical. Any gap in the metal enclosure is a weak point. I take aluminum foil and carefully cover the seam where the lid meets the box, then tape over it. You want a complete metal seal all the way around. For containers without tight-fitting lids, you might need to wrap the entire seam in multiple layers of foil. It doesn't have to be pretty, it just has to be conductive and continuous. For my final confidence test, I set up 2 identical devices. One went into my fully shielded Faraday box, sealed tight. The other I left on a table nearby, completely unprotected, just to see the difference. Big storm came through, lightning everywhere, the kind that makes your teeth hurt. I waited it out in my shelter, confident in my shielding work. Storm passed. I opened the box. The protected device worked perfectly, powered right up, no issues. The unprotected one on the table, completely dead. Wouldn't even turn on success. There was just one small problem. When I stood up to celebrate, I noticed my hair was standing straight up with static, and the sleeve of my jacket had a small singed mark on it. Apparently, I'd been standing too close to an ungrounded metal shelf during the storm. But you know what? The shielding worked. That's what matters. My electronics survived, and that means communication, navigation, and precious data all stayed intact. In a post-apocalyptic world, that's the difference between thriving and just surviving. So, there you have it. Faraday shielding. Easier than you think, more important than you know, and definitely worth the occasional singed eyebrow. Stay safe out there, protect your gear, and remember, seal first, celebrate later.